Hi friends, this is your Srinivas. Today I am going to discuss about and its graph and its properties also. See, a function f of x is equals to x minus step x is called fractional part function. It is also denoted by bracket set bracket x. The set bracket x denotes fractional part of x, where set bracket of x is equals to x minus step x. Say set bracket of x is equals to fractional part of x. Here x minus step x represents the greatest integer function, which is already we have discussed in our earlier videos. Okay, now let us draw the graph of fractional part function. See, to draw the graph of fractional part function, we have to select x values independently and we have to represent on this coordinate system corresponding f of x values. Suppose x value is 0, set bracket of 0 is fractional part of 0. That is nothing but set of 0 is equals to zero minus step 0, which is 0. Step of 0.1 is equals to 0.1 minus step of 0.1. Of course, step of 0.1 is 0, which is 0.1. Means 0, x value 0 corresponding f of x value also 0. X value 0.2. See, x value 0.1 corresponding f of x value also 0.1. X value 0.2 corresponding f of x value 0.2. X value 0.5 corresponding f of x value also 0.5. X value 0.9 corresponding f of x value is also 0.9. Now, the graph between 0 and 1, from 0 to left side of 1, this is the graph. Okay. Thereafter, at 1 it is 0, at 1.1 it is 0.1, at 1.2 it is 0.2, at 1.9 it is 0.9. So this is the graph from 1 to left side of 2. At 2 again it becomes 0. At 2.1 it is 0.1. At 2.2 it is 0.2. At 2.5 it is 0.5. At 2.9 it is 0.9. So this is the graph. This is the graph from 2 to left side of 3. At 3 it is 0. Again same thing will be happened. This is the graph. Similarly, this is the graph. And here also we get this is the graph. Here it is. This is the graph. See, actually the graph is just a straight line part or else a line segment, but to show you clearly I am drawing it is thick. So don't worry about that and don't think how we are getting graph is like this. Okay, just for our convenience I am drawing this much thick. Okay, so this is the graph. Observe that graph is always lies between, this is y is equals to 1 line and x-axis means it is y is equals to 0. So there are only two boundaries. There are boundaries for the graph and they are y is equals to 0 and y is equals to 1. Means graph reaches maximum value is 1 only. So that's why it never crosses the line y is equals to 1. It never be above that line. Always lies in between y is equals to 0 and y is equals to 1 only. So that's why its range is closed interval 0 comma 1. It never be equal to 1. That's why open interval 1. So its minimum value is 0, maximum value is 1. And observe that is the graph is increasing or decreasing? 0 to 1 it is increasing, 1 to 2 it is increasing, 2 to 3 it is increasing, 3 to 4 it is increasing, but 2 to 2.9 it is increasing, at 3 again it is coming down. So we can't say whether it is increasing or decreasing. And also if we draw a line parallel to x-axis, graph, this line is intersecting the graph at infinitely many points, so that graph is not one function. And for every graph we are checking the nature of periodicity. Here function is periodic because 0 to 1 whichever the graph we are getting, same type of graph we are getting from 1 to 2 also, from 2 to 3 also same graph, from 3 to 4 also same graph, from 4 to 5 also again we get same graph. So that's why graph is repeating for every interval of length 1 unit. So that's why its periodicity is 1. Its period is 1. It is periodic function. Its period is 1. Okay. And also continuity nature. Can we say that graph, or can we say that this function is continuous everywhere? No. It is continuous from 0 to left side of 1. But at 1 it is breaking, so that it is discontinuous at 1. Again it is discontinuous at 2. Again it is discontinuous at 3. So graph of a function is discontinuous at integer points. So that's why graph is continuous everywhere except integer points. Okay, of course, differentiability nature also. It is having sharp edge at 1, at 2, at 3. Sharp edge means there is a break. Wherever the function is discontinuous, there it is non-differentiable. So that's why function is not differentiable at all integer points. Okay, so these are the properties. Let us check properties of fractional path function. And already we have checked that. What about its domain? Graph of this function is defined everywhere. That's why domain is R. Range of this function is closed interval 0 comma 1 open. Why? Because it never be equals to 1. Whichever the value of x you consider, even x is equals to 2 you take, 2 minus step 2 is 0. X is equals to 2.1 you take, 2.1 minus step 2.1 is 2. 2.1 minus 2 is again 0.1 only. So that's why it's never be equals to 1. So because of that reason, we are writing range as closed 0 to 1 open. And observe that f of x is equals to fractional part of x is continuous on r minus z. It is continuous everywhere except integer points. Okay, f of x is equals to fractional part of x is differentiable. It is differentiable everywhere except z. F of x is equals to fractional part of x. Minimum value is 0. Maximum value is 1. Maximum value 1 means it never be equals to 1, but its upper boundary is 1. So that's why we are writing maximum value is 1. F of x is neither increasing nor decreasing, and f of x is equals to set bracket x, means fractional part of x is a periodic function its period is for every interval of length 1, that length 1 is called its period, and f of x is equals to fractional part of x is not one function. How did we decide this? By drawing the line parallel to x-axis so that it is intersecting at many points. Is not one function. Okay? So these are the properties of fractional part of x. Okay? Fractional part of x graph is always looking like a straight line. Okay? Not only a straight line whose slope is equals to 1, means whose inclination is 45 degrees. See, our next function is Signum function. Okay? F of x is equals to modulus x by x, where x not equals to 0 is called a Signum function. It is also denoted by Sgn of x. Sgn stands for Signum of x. So Signum of x is nothing but minus 1 whenever x less than 0, plus 1 if x greater than 0. Okay? Observing definition of Signum function, it is not defined at x is equals to 0. X less than 0 it is defined. Of course, x greater than 0 also it is defined. For x is equals to 0, it does not exist. See, according to the definition, whichever the value x you consider as negative, suppose x is equals to minus 1, it is minus 1 only. For x is equals to minus 2, it is minus 1 only. So whichever the negative value you consider, its outcome is always minus 1. Minus 3, minus 1. Minus 4, also minus 1. Minus 4.5 is also minus 1. So minus 0.3 is also minus 1. So this is the graph whenever x is negative. It does not exist at 0. And also, whichever the value you consider which is positive real number, its outcome is plus 1. It is very easy graph. 0.1, it is plus 1. 0.2, it is plus 1. 1, it is plus 1. 1.5, it is plus 1. 2, it is plus 1. 2.5 plus 1. 3.5 plus 1. 5 plus 1. At 0 it does not exist. So this is the graph of Signum function. Okay? It is defined only for negative real numbers and positive real numbers. That's why its domain is what? Defined everywhere. Graph exists for each and every real number except 0. Left side of 0 graph exists, right side of 0 graph exists. Graph does not exist at 0. That's why its domain is set of all real numbers except 0. And also, what is its range? What about graph? Graph is always either minus 1 or plus 1. This is y is equals to 1. This is y is equal to minus 1. These are boundaries, of course, but there is no graph between these two lines. So that's why graph is consisting only these two lines, namely y is equal to minus 1 and y is equals to 1. So range contains only two types of elements. Those are y is equals to minus 1 and y is equals to plus 1. It's the minimum value minus 1, maximum value plus 1. And also observe that how to check its one nature? By drawing a line parallel to x-axis. If such line intersecting the graph at more than 1 points, it is not 1. Check whether such line exists or not? Suppose if I draw a line parallel to x-axis like this, it is intersecting the graph at infinitely many points, so that it is not one function. Check whether it is increasing or decreasing. For 1, x is equals to 1, graph corresponding point is 1. X is equals to 2, it is 1. X is equals to 3, it is 1. As x values are increasing, corresponding f of x values are not increasing. As x values are increasing from left to right, f of x values are not increasing. Of course, not decreasing also. It is neither increasing nor decreasing function. Is it a periodic function? To say that function graph is periodic, there should exist graph, same type of graph. There should exist same type of graph after certain interval. There is no such situation. That's why it is not a periodic function. Continuity nature. How to check whether the graph is continuous or not? If we can draw a graph of a function without lifting a marker from the board, then it is called a continuous function. Of course, we can draw the graph left to right till here without lifting the marker from the board. But here we have to lift. We need to lift. Thereafter we can draw the graph continuously. So at 0, we have to lift the marker from the board. So that's why function is continuous everywhere except 0. Of course, domain is also not containing 0. We can say that function is continuous on its domain. Next, how to check its differentiability nature? Wherever the graph has a sharp edge, or else graph is discontinuous at a certain point, at those points it's not differentiable. So it is continuous everywhere except 0. So that's why it is not differentiable at 0 also. So these are the properties. Let us write properties. So see the properties. Already we have discussed observing the graph. Once again I am explaining you. F of x is equal to signum x. Domain already we have seen. It is defined everywhere except 0. That's why domain is r minus singleton set 0. A range is equals to. A range contains only 2 elements. In the previous graphs, in the previous videos, a range is always an interval. Interval is an infinite set. But here the range containing only 2 points. Those are minus 1, 1. By observing the range, we can say that minimum value is minus 1 and maximum value is plus 1. Very easy to identify. And also, it is neither increasing nor decreasing. Already we have seen through the graph. It is continuous on r minus 0. Except 0, it is continuous everywhere. It is differentiable on r minus singleton set 0. It is not one function. Why it is not one function? If we draw a straight line, there exists a straight line which can be intersected the graph infinitely many points which is parallel to x-axis. That's why it is not one function. It is not a periodic function. Why it is not a periodic function? Same type of graph is not going to repeat after certain interval. So that's why it is not a periodic function. So these are the properties of Signum function. Signum function is very easy function. Just modulus x definition we should know thoroughly. If x is positive, mod x will come out as x. X by x is 1. That's why a second case x greater than 0 as 1. If x is negative, mod x will come out as minus x. Minus x by x we are getting minus 1. That is first case. So there are only 2 types of cases exist. If x is equals to 0, function does not exist. So that's why it is not defined at x is equals to 0. So friends, if you like my video, please subscribe and leave a comment in comment box and encourage me to make more videos for you. Thank you.